Hey, hi everyone. Good evening. I hope everyone is able to hear me. Hey, hello all. You're able to hear my voice, right? Let me turn on the screen share. Wonderful. All right. So we are going to talk about data engineering, right? So let me begin the session now, and right, let us try and understand what exactly is data engineering and why so much of fuss is happening in the market with respect to data engineering specifically. Now, when I started my journey in data science, almost close to a decade, it's 7 to 8 years now, there was not so much of rigmarole. It was very simple process. We used to have data given to the hand and we used to work on that. So it was very simple thing. But as and how the world is in fact moving into digitalization, a lot of data is generated, right? And thanks to internet, thanks to globalization, we all know what data science is now, isn't it? And we can learn data science from various forums. And of course, it is required for the organizations to take advantage of the data, and data science play a crucial role for businesses to take that advantage. Then why data engineering? Whenever we talk about data engineering, I would suggest you to remember one point, which is end-to-end data pipeline. Data engineering is nothing but data pipelining. This is the synonym that I want you people to remember. All right? Now, let us try and understand what exactly is this data science and AI, right? This is something you all know. So I'm going to do a quick revision here. So when we speak about the new age technologies, then we need to speak about AI. You're trying to automate a lot of redundant jobs and you're trying to utilize humans for much more intelligent works, right? All the dirty works and all those things have to be moved on or automated using AI techniques, right? Then in order to identify what all those areas are where data or AI can be automated or AI can be implemented, we will be basically deciding that after doing some research on the data. Data scientists play a crucial role here to direct the teams to automate certain things. And in order to implement the solution, we use data mining techniques. This is to churn the data. And here, when we speak about data churning, we will look at machine learning and deep learning aspects. And we know machine learning is basically the technique which is used for train the machines if your data is in structured format, wherein we try to bring out a mathematical model for your business problems. In other words, I'm taking the business model and representing that on mathematical model. right? So that is about machine learning. Now, if my data is unstructured and if I have to try and train or try and make sure that the data becomes structurized so that my computer learns, then we will be looking into a concept called as deep learning, right? Now, this deep learning is a technique which is going one step deeper to make sure that the unstructured data is becoming structurized. This is how we basically define the deep learning aspects. We also have advanced techniques. We'll also see something called as reinforcement learning. But till here, if you are familiar, very good. If not, then hope the high level definition is giving you some direction on what exactly these things mean. Now, using all these techniques, when you're trying to implement a solution, we'll start with understanding the past. This is where analytics kickstart, and we use BI tools, right, to tell visual stories or data stories. We visualize and tell stories about the business. Then we'll also implement machine learning models, predictive models. Using this, we are trying to estimate the future. And then, using that information, evaluating that information, we will try to strategize or devise a strategy which can put the organization in the right direction to generate good revenue. Then, if I automate this entire process, wherein I remove the human intervention completely, then it becomes, the implementation becomes a AI solution for the organization. These are different stages of your implementation of analytics, right? And as I mentioned, we also have reinforcement learning. Reinforcement learning is a learning or is a technique which allows the machines to train themselves. In these two areas, machine learning and deep learning, we need basically a labeled data for training purpose. Of course, we'll also work with unlabeled data for generating reporting, and supervised learning techniques will be applied there. But you have to train. Whereas in reinforcement learning, you are not training the computer, the machine. The machine itself starts training. You are right. You are basically, all you're doing is instructing that algorithm that there are certain conditions. You're putting that in an environment and saying these are the conditions. That's it. And the machine tries to learn based on reward and penalty concept. If the algorithm is doing the right thing, then it gets rewarded. That means it's the correct thing, right? So computer knows that, okay, this is reward and I did the correct thing. If the computer does a wrong thing, then it gets penalized. Now, what is this reward? What is this penalty? That's a different story altogether. There's a whole lot of things that we'll have to discuss in reinforcement learning. But yeah, that's not part of the scope of this discussion. But as I explained, reinforcement learning means rewards-based learning, wherein as a user, as a ML engineer, you are not going to train your algorithm. It is going to do it for itself. So these are some of the things that are there in the world, and we know majority of people know this. Now, where did data engineer coming in picture in this value chain? Why suddenly data engineering is being spoken about? So if you actually break down what exactly is data engineering and what are the roles and responsibilities of a data engineer, then it becomes very easy to try and grasp on the roles and responsibilities, and you can upskill on data engineering profile. Basically, you can upskill yourself to become a data engineer. So let us see what exactly is data engineering. And I'm trying to make a comparison of data engineer with data scientist. So how is these two different? The data engineers would generally come at the planning phase, right? And they become the link between the data strategy and the data scientist. When I say data strategy, and I'm using this word, data strategy basically means the systems which or where the data is getting stored or generated, you can see. I would simply say data systems. It could be management, it could be some tools, it could be some software. But data engineers become the link between the data systems and data scientists. Because for data scientists, data is everything, isn't it? Without data, they cannot do anything. So we need data engineers so that data scientists get the data, right? Data engineers are basically responsible for designing, building, integrating data from various resources. There will be different resources where data gets generated, right? So we are basically responsible for designing that architecture, building the architecture, and trying to make sure that these different data systems communicate with each other and can be integrated with the existing systems. And we should be able to manage all that data that is coming in. It becomes big data. In short, building and maintaining data pipelines, that is the primary role of data engineer. So in other terms, data engineers are the people who are responsible to make sure data is accessible. Whatever you want to do, data is the primary key. You need that data, right? Data engineers are responsible to make sure that that is accessible for different stakeholders in the value chain. It could be analysts, it could be data scientists, it could be higher management. Different teams could be there, back-end team, front-end team. For all of those people, all those different touch points, data should be available, right? So they generate this data pipelines. Then we have ETL. Sorry, yeah. We have ETL job. So when I say data pipeline, it is nothing but ETL job. Extract, transform, and load the data which is coming from different sources. So if you have data generated from different sources, you need to extract that. Then you are trying to transform it so that it can be consumed. Some pre-processing happens here. And then we load it into either a data lake or a data warehouse. There will be a data lake or a data warehousing system where we push or load this data for different stakeholders. So this is the primary job of data engineers. Whereas data scientists, you already know, they are basically capable to do statistical and machine learning implementations. They basically have very good analytical approach to the business problems. They try to convert the business into mathematical model and give actionable insights, directions to the teams, right? And they are expected to explore the data, generate reports, do predictive analytics, try and estimate the results, right? And yeah, they basically should, in short, they should have knowledge on different things. So hope this discussion is giving you a clarity on what is data engineering and what is data science, right? Roles and responsibilities. Now let us also talk about a few more things here. I will be speaking about the process management methodology, which is supposed to be followed by data scientists. So when you talk about data science, I'm pretty sure that majority of you people are familiar with data science skill set. You may want to confirm that on the chat window. Yes or no? You can basically say yes or no. Yeah, friends, are you not able to hear me? Let me check. Okay, great. Okay, I see your messages now. Wonderful. All right. So when we speak about data science, right, you all are familiar, right? At least 90% of the crowd that has joined today are familiar with the data science process. So we also know what is the process methodology that we follow. Again, you might want to put that in the chat message. What is the process that we follow? Process management methodology. Yeah. Very good. Wonderful. So it is crisp DM. All right. Now, like any other process or any other thing, crisp DM also has evolved. Okay, it has evolved itself. Because when we speak about crisp DM, it does not speak about continuity. This is one of the major challenge with crisp DM. When we talk about implementation of a analytical solution, continuity is one big problem that we need to look into, right? So to make sure that the crisp DM is actually used for a continuous implementation of a solution, there are small updates happen to crisp DM, and we call now this as crisp ML. Same name, but we say crisp ML, cross industrial standard process for machine learning implementation. It is also 6-step process. There is no difference. Here also you will see 6-step process. What are the steps for crisp DM? We speak about business understanding. Then we speak about data understanding. Then we talk about data pre-processing or data preparation. Then we talk about data mining or data modeling. Then we talk about evaluation of the model. Finally, we speak about deployment. This is your crisp DM methodology. But if you look into this crisp DM methodology, there's nowhere it is suggesting about cross-verifying whether these steps that we are following are correct or wrong. That means biggest point of any software product development, or any development for that matter, any product development, is testing. Now that testing part is not included in CRISP DM. So CRISP ML was specifically developed to include that quality aspect. Right? CRISP ML is specifically developed to include the quality aspect. And another point which CRISP DM does not speak about is continuity. Right? So these two are captured in CRISP ML methodology. There are, as I mentioned, slight changes in this CRISP DM 6 steps. So those are, to start with, the first step is business and data understanding. Business and data both have to be interpreted in line with each other. If you're speaking about retail business, then the data that we speak about should be in line to that business. The conditions of the data that is getting generated in that business needs to be understood. The features that are getting generated in that business should be mapped back to the business. So you cannot separate business understanding and data understanding. Generally, these two are combined together. They have to be analyzed together. Next comes the data pre-processing or preparation, and this is where you see data engineering coming into the picture. Data preparation, making the data available for the next stages, is exactly the role of a data engineer. And the rest of the things are following up. Once the data is ready, then your machine learning implementation can happen. Post that, you are going to evaluate the model and of course fine tune it so that the performance becomes better. Then we deploy the solution, and after the deployment, you also have to make sure that the solution that you have developed is working correctly as expected. Even if there are certain changes, right? There could be various changes that we will see. Your model should be robust of all those political changes, financial changes, climatic condition changes, right? COVID scenario kind of changes, pandemic kind of changes. So irrespective of these different factors which are influencing the business, the solution that we have developed should also get in line, get adjusted to work with those conditions. So you have to make sure the solution is maintained, right? It has to be maintained and constantly being monitored. So these are the two important points that you have to remember, which are the additional changes that from CRISP DM methodology. Right? Next. Now, when we speak about this CRISP ML methodology or any analytical solution, machine learning or AI related solution being developed, all these years, we were learning that the solution will be developed for a given condition and on given data. So you will get a sample data. And what we do, we implement our statistical and machine learning concepts and we extract statistics. We obtain statistics. And from these statistics, we make estimation for parameters. Estimate parameter. But is it a one-time activity that you're doing? No, right? Analytics should be a continuous process. Whatever the solution that you're developing, it has to continue. But for continuation, you also will see new data coming into the picture. So if new data is coming, should I take that entire new data separately and redo this entire task? Right? So you have to think about it. So yes, we have to. This is where we call it as CD and CI pipelines. Right? Continuous development and continuous integration should happen. And the solution that you have developed should work seamlessly, irrespective of the tools and techniques that we are using. When new data coming in, then that new data should follow the entire process and it should be able to give us insights, business insights. It's a continuous process. Now, if I have to enable this continuous process, what all things I need to do? Yep. The first thing is make sure that the data flow is continuous. If your data is flowing continuously, then you'll also be able to implement the solution continuously. Isn't it? Now, all the industries, right? In whatever the industry you speak about, a lot of data scientists are already developing the solutions. There's still a lot of demand for data scientists because organizations want to take the leverage, right? Want to take the advantage of the historical data that they are capturing. But in order to do this, right, in order to achieve this, we need a continuous pipeline in which the data is flowing so that data scientists can work. That means data engineers are also in demand now. And this is what you're seeing. All these are recent articles, right? Reference is also given. If I try to click on this, it will redirect to this particular page. 9 predictions for data engineering in 2001. Product focused data engineer roles are on the rise, right? They are also being asked for enhancing their skills because we will deal with a lot of tools. It will enable data engineers to easily connect with these different systems. So there is overlapping, right? The lines between data engineers and data scientists will continue to blur because there is a lot of overlapping happening, right? Similarly, if I talk about data engineering is in focus. This is in the page, right? The Hindu. Here also you can see that as the demand for collecting, storing, and analyzing information is on the increase, this role is gaining prominence in the tech ecosystem. Data engineering in focus. So on and so forth. Right? All these different links speak about the same thing. KD Nuggets, which is a very, very popular research firm, right? And a lot of consulting firms, research consulting firms, Interview Query, these firms are saying that the increase for data scientists and data engineers has gone skyrocketing. Data engineers, right, specifically, you can see 40% rise demand for data engineers. Data analysts, data scientists increased by 20%. So jobs are, plenty. You just have to capture that opportunity. And data engineers are also demand, high packages. And this is the information from Glassdoor and PayScale. These are the two popular job consulting platforms. And I can also, you can also do it. Just do a Google for this, and you will see the average salary is shown here, around about 8 lakhs, right? So yeah, it is very similar to data scientist job role, right? In fact, there are a lot of roles and responsibilities where overlapping happens, right? Now, what are these people required to do? As I mentioned, data engineers are required to develop data pipelines. A pipeline can be imagined as a task of moving data from point A to point B. Now let us imagine this. You have, let's say, overhead tank. Okay, there's overhead tank, and there are a lot of houses. This is a small community. Okay. In order to get this water, we basically bring in the water using pipelines, right? All the houses are connected with pipelines. That means water is flowing from point A to point B. If I speak about a single house, let's again talk about a single house here. Do you think the inlet is only to one place? In your house, do you have one tap, one place where you collect data? Collect water? No, right? There will be different points where you are going to collect your water for different purposes. The consumption of that water is different. Same way, our data engineers are responsible to build this pipeline in which the data is seamlessly flowing, continuously flowing, right? And the different stakeholders who want to consume the water or consume the data in this case. I'm trying to draw parallels here, right? So just like how we different people consume, like in kitchen, you use the same water for probably cooking, right? Maybe in your sinks, wash basins, you basically use it for cleaning your face or cleaning utensils, etc. In washing area, you're washing the water, using the water with, cleaning your clothes using the water. So purposes are different, but water is same. Same way, here imagine data is getting generated. This could be your DB source, database source, where data is getting generated. And data engineers are constructing these pipelines so that the data is flowing. And whoever wants to connect and use the data for a specific purpose, they will be able to do it. Now, data engineers also have to manage and maintain this pipeline, and they make sure that the data is flowing without any problem and at a good performance, at a good speed, basically. No leakages should happen, right? So data engineers design, build, integrate, and maintain these data pipelines. So you will have multiple sources. You may not have just one source. For example, if you take Amazon as an example, okay? Amazon has their customer database. They'll also look into web traffic on their web page, right? They'll also see external other websites where the customers might be clicking on different various things and all the ads and all that. So different touch points would be there. So data is getting collected from all these different touch points, and you are going to process it, prepare it, transform it, and then you load it into a data lake. Here we are extracting. We basically also call it as ingestion, data ingestion stage. These are your sources. Then you extract, then here you will transform. Transform is the stage where you can say you are pre-processing your data. Right? And then you will store the data, load the data into a persistent storage device. So we basically have data warehouse or data lake. Okay, these are two options that you can put your data into. And here you will have ML engineers, you'll have data analysts who use BI tools to do that. You will probably have other systems which will consume this data for their marketing purpose or their other businesses purposes, right? You'll probably have APIs which will use this for report generation, so on, so forth. This is a typical data pipeline that we are seeing. Now, when we talk about this data pipelines, the data pipelines can be of three different forms. One is batch data pipeline. Batch data pipeline basically means that the extraction that you are doing, the ingestion that you are doing, will be done at one time. Probably for an entire day, you extract the data once. That means all the data that is accumulated here is pushed to the next level once. Right? Extract once. If I say streaming data pipelines, these are event based. Generally, they get triggered when data is getting generated. As soon as a transaction is initiated, right? Here we say transactional data. As soon as the transaction is generated, the data has to be pushed to the next level. So this is a continuous, right? Live streaming of data happens here. Continuous flow happens basically. We also have the third option which says CDC pipeline. CDC pipeline basically means change data capture. So you have data, you have pushed the data to ETL process. Assume, and you're storing that into a data lake or warehouse. But there is some change happening here, right? There's some change. The data is already pushed, but after that, there is some update happening to the data, right? Now, whatever is changed, only that has to be updated into your data warehousing tool. So data which is changed, that has to be captured. So you're just trying to do refresh of your data, which is already there in data warehouse, so that there is a sync of your data, right? There should not be misinformation in these two cases, right? Identical data should be there. So this is change data capture concept, which can again be designed live or it can also be designed as batch mode. So these are the three broad variants of data pipeline architectures that are defined. Right. Next. As I mentioned, data pipeline, you can see this is a typical data pipeline diagram where we are talking about sources. There could be messaging system. There could be APIs which push the data, your database, your flat files, or big data. The elephant is basically representing Hadoop. All this data has to be ingested. Data ingestion means collection, importing. And it can be done either streaming way, refreshing way, or batch way. We get the raw data here. We are integrating, accumulating all the data and doing ETL. Extraction is done here. We are doing transformation here. And then we are loading this into data lakes or data warehouses. Maybe you are doing both. And from here, all these end users will come into the picture who are the consumers of the data. Right? So this is a typical data engineering flow diagram. All right. Now, when we speak about data pipeline, your machine learning implementation is also having this flow. You need to get the data, only then you will be able to implement the solution. But you cannot take the raw data as is. So you will be doing data pre-processing or data preparation. And post that, we do model choosing. Which model will work here? Should I go with the regressor method? Should I go with classification model? In regression, which model should I use? In classification, which model I should use? Right? All these things are happening here. Model choosing techniques. Once the model is chosen, the training begins. But just training is good enough? No. We have to tune the model. We have to evaluate, understand how good it is working, whether it is satisfying all the business and reality conditions, applicability conditions. If yes, then can I fine tune this model? If you can do that, then you will get the best model out. And that best model will be used for predictions or usage purpose. You're deploying that. Right? So this is a typical data pipeline for your ML implementation. In short, we call this as ML pipeline. And this has to be a continuous process. So you will bring in some tools here. You will bring in some tools here. You will bring in some tools here. Tools are maybe techniques, or you can say frameworks or code, so that this entire process is seamlessly, continuously working. Now, as a data engineer, remember I told that data engineers are generally coming in planning phase of your project life cycle. So you will have to be deciding on what tools and techniques, or you can say products or services, you can call it with any name, right? What are those things which are required, hardware and software, right? Entities required, resources required to enable this continuous flow. And thanks to this study, a lot of process which is redundant is being automated. Right? The process is getting automated. And that is exactly what we call as auto ML, or you say auto AI. A lot of frameworks are now they're available which can basically do this auto ML or auto AI. Okay. And when we talk about data pipelining, we need to look into the architecture. Planning phase, you will have to define the entire architecture of how data is going to flow from point A to point B. When I say point A, it could be multiple points. It could be multiple points. And in this entire journey, do we have any other touch points? So this entire architecture has to be designed. And there are a lot of architectures which are right in usage, right? And we will be learning about those architectures. And when we speak about those architectures, Lambda architecture is one of the oldest and very, very popularly used architecture in big data environment, in production environment. We also have streaming pipelines. We also have something called as Kappa architecture. We also have batch mode, right? So all these are different architectures which are available in data pipelining design. Now, as engineers, data engineers, you're also responsible to use the right tool. And these tools should satisfy certain conditions. So what are those factors that we have to keep in mind? The first thing is the setup should be done in a very, very minimal time and an easy way. So do I have any graphical interface tools, or do I have to write a lengthy code? That's the first thing, right? There are both the options. Based on your comfort level, you will have to choose what technique or what tool is better for the business and for you to deploy that pipeline easily and quickly. Then, once you decide on the tools and techniques, and once you design and implement the pipeline, you also have to maintain it. So does the solution, that the pipeline that you're using, right, the tool that you're using, does it require a lot of overhead to maintain the pipeline? If yes, then obviously it is not a good choice. Data is coming from various sources. So your pipeline tools should be able to connect, communicate with all these different sources, right? And then it should be able to extract the data. And it should make sure that the tool right, that we are using, it should make sure that the data does not get leaked. Data reliability is one of the important factors that we have to also look into. Data is moving from one location to another location, so there is always a chance of leakage. So we should be able to track and control the leakage. In fact, there should be zero leakage, right? And the tool also should be able to push the data on live streaming scenarios, live data scenarios, right? So these are a bunch of features or factors which we need to look at with respect to deciding on a data pipeline. I mean, the tool that we are using. And in order to talk about this, we will have to look at the starting stages data sources. And we have RDBMS being the first source that we'll have, right? RDBMS database software is still the primary choice for storing the data. It's a repository where the data gets stored, right? So database softwares are the primary choice. But we also have various other options where the data is getting generated. And in order to deal with all these things, we have a lot of tools that we should be able to do a hands-on, explore. Apache NiFi is a graphical user interface, drag and drop kind of a tool where you will be able to design your pipelines and implement them. Apache Airflow is a command line interface based workflow management tool, which will allow you to design your pipelines using Python code. Spark, it has amazing capabilities, and it is one of the popular tools by tools with respect to data engineers. And Apache Kafka is used for streaming the data, live data. So Spark and Kafka are the very, very popular tools. Both of them are open source, which are used for designing the pipelines. But you also have to be familiar with data sources, because ultimately you are going to deal with the data which is stored in certain softwares. So SQL and NoSQL queries is something that you should be familiar with. Then we have Amazon Redshift, GCP BigQuery. These are data warehousing tools, right? BigQuery is very, very popular. It can handle petabytes of data, not even gigabytes or terabytes. We're talking about petabytes of data can be very quickly queried on using BigQuery. Right? Redshift is also on the same lines. We have Python for processing, related stuff, and big data Hadoop, and for serving layer for dashboards, we will have to learn Tableau. This is basically the end-to-end journey of the data, right? So from SQL databases or NoSQL databases, the data might be showcased on dashboards in Tableau. So you should be able to integrate and make sure that the data is pushed through all these data systems without any problem. So this is data engineers' roles and responsibilities to start with. All right, so I will be stopping the session here, and in tomorrow's session, we will talk about the architectures, data architectures. Well, I'll detail about what steps we will have to look into while we talk about data architectures. All right, friends, so that's it from my side for the day, and we shall connect tomorrow. See you guys tomorrow.